graupel particles really look like cones, which is kind of nice when you're thinking about the snowflakes having their own little ice cream cones. Hi, my name is Nina Mayhandel. I'm a doctoral researcher at Leipzig University, and I make videos talking about research in the Arctic, especially focusing on clouds and snow. And today's video is kind of a follow-up on the last one about snowflakes. So there I talked about why snowflakes look like they do, how they are formed, and why I personally get a tiny bit angry when I see snowflakes drawn with 8 sides. So if you have not seen that yet, feel free to pause this video, go over yonder and learn about the basics, then come back to this one for the bit more weird stuff, because today I'm going to show you 3 weird looking types of snowflakes that occur in nature and discuss how they are possibly formed. You are still here, right? Alright, your choice. And if you're back, then welcome back. Let's get into it. Ice crystals that make up snowflakes come in a bunch of different typical forms. They often look like this, which is called a dendrite and probably what you picture when you think of a snowflake. But snowflakes can also consist out of these thin ice needles. If you have a spherical, round, dense snowflake, then we call that graupel. So graupel form in clouds that not only consist out of ice crystals, but also have liquid water in them. So liquid water drops can occur in temperature ranges below freezing in the atmosphere, which is then what we call in a supercooled state. At that temperature range, so below freezing, water would prefer to be ice, so prefer to be frozen, energetically speaking. However, liquid drops need a little push, so a little extra energy for that. And that is provided when they come in contact with already frozen ice. So when a supercooled droplet and an ice crystal collide, then the liquid droplet freezes and it sticks onto the ice crystal. And that's how graupel forms, because the ice crystal is typically much less dense. So if you're thinking about the dendrite, it has these different branches, and then the liquid water droplet, which is much smaller, comes into contact, freezes onto it, and it typically fills these gaps in the dendrite. And that leads to this compact graupel form. There's a rather rare type of graupel observed in nature, which is called conical graupel. Conical due to its shape, so these graupel particles really look like cones, which is kind of nice when you're thinking about the snowflakes having their own little ice cream cones. The baffling thing about conical graupel is that we, as the science community, don't really understand how they form. So there is a suggestion from a rather old paper, I think from 1972, which sounds like the following. So you start from a plate-like ice crystal, which falls kind of horizontally due to the aerodynamics and is exposed to an air mass where you have liquid droplets in there. The liquid droplets are much lighter than the falling ice particle, so they are more or less floating in the air. And if it's falling down, the air streams around the ice crystal, and the liquid droplets kind of follow this stream. If they come in contact, they freeze onto the ice particle and do so preferably at the sides, since they kind of follow this airstream. Then you get these almost branches forming on the edges on the ice crystal, because there the liquid droplets freeze onto there rather than in the middle, and you have these branches sticking out. So if we have our particle here, you have these branches sticking out, and then if they are long enough, they kind of come together at the top and form this cone-like shape. At least that's this suggestion. As far as I'm aware, this was not proven in lab studies or so far, and it leaves some open questions. So the mystery about how conical graupel is formed is not fully solved yet. A colleague of mine is studying conical graupel observations in the Rocky Mountains, so maybe he's gonna come up with better explanations, we'll see. Coming from ice cream cones to another type of sweet, ice lollies. Almost like ice crystal researchers or snowflake researchers have a sweet tooth, or maybe that's just me. I mean, ideally, if I stumble upon a new weird type of snowflake shape, I could call it ice chocolate or ice cinnamon buns or ice cream. That's not working, no. Anyhow, ice lollies look like you would expect. At least I hope that's what you picture when you're thinking about lollies. So you have these rather large looking droplets, frozen droplets, and a kind of thin needle, a thin stick sticking out of there. And they form again in clouds that contain not only ice crystals, but also liquid water. And again, we're talking here about temperature ranges well below freezing. These ice lolly snowflakes are very rare, at least in terms of observation. So there's one study where they observed them during aircraft measurements over the UK. Also, we in our working group made some ice lolly observations in New Orleans in December 21 with our snowfall camera there. So here's some pictures of that. I know they look rather bad quality, but keep in mind these ice lollies are very small, so they are oftentimes less than a millimeter in length, and the snowfall camera is trying its best. It's doing a good job, so don't be too hard on it. But how do they form? You need large droplets at the cloud top, or let's say further up in the cloud than the ice crystals. These droplets need then to be large enough to actually fall down due to gravity. And then below the liquid water layer, you need thin ice needles, which can form, for example, via secondary ice production. So I have another video on that if you're interested. So the droplets collide with the ice needles, and then it works similar than with graupel, except this time kind of the sizes are reversed. This time the droplets are larger and the ice needles rather small than the other way around with the large ice crystals and the small droplets. Anyhow, the droplet freezes, and this results in this ice lolly form that can be then observed either in the air or on the ground when they precipitate to the ground. In the Arctic, liquid droplets at cloud top in a supercooled state, so at temperatures below freezing, are rather common. So possibly ice lollies are more common than we think. However, keep in mind, in the Arctic, observations are really tough and therefore limited. And last but not least, my favorites from this list. No sweet this time, although if you can think of a sweet that kind of looks similar to this, then let me know, because columns on capped columns is a name that needs some improvement if you ask me, although it is a bit funny. Reminder, if you have not seen my last video, boo, or if you have just forgotten, you can get these ice crystals, which we call capped columns, when you have first the ice crystal snowflake growing in a column-like temperature range, and then it either goes to a temperature range colder or warmer, where plate-like growth is preferred, and you get these plates growing on the edges. So these are what we call capped columns. During a field campaign in 2019 in New Orleans, so again, New Orleans, researchers observed this capped columns, which again had little columns attached at the edges, so another round in this iteration basically. So they observed columns growing on plates, growing on columns, and they did these observations with an instrument which can provide very high resolution images of ice crystals in clouds. They mounted that on a balloon and let it fly in the cloud. In their study, they proposed that these types of snowflakes form by the ice crystals circulating through the cloud through different temperature regimes. So they start out in a regime where column-like growth is preferred, between -3 and -10 degrees Celsius, roughly speaking, and then they are either lifted to colder temperatures or they fall to warmer temperatures and transition into this plate-like growth regime where the plates on the edges grow, but then they circle back into the column-like growth regime and you get these columns, so these sticks poking out on the sides again. In my head, I imagine these little ice crystals going round and round in the cloud, going like, one more round, one more round. I'm personally looking forward to then in a couple of years when we have instruments with even higher resolution and you get these maybe capped columns on capped columns or columns on capped columns on capped columns. I know you get the gist. Anyhow, I hope you learned something new. I'm sorry for the rather short video this time. I'm pretty busy at the moment. So last week I was super occupied with working in the reviews for my second paper, so I completed a revised version now. This week I participated in this training module on satellite observations of cloud development, and the next week we have a conference in Leipzig, so for this research project that I'm part of, and I'm presenting there and also helping a bit with the organization, so it's just a lot of stuff summed up currently. There was a request for a video, kind of like day in the life of a researcher, which I am very happy to make in the hopefully not too distant future. Also, I want to do a second part on Arctic exploration, so stories about historic Arctic expeditions. I mean, there was a request for talking more about cannibalism, so I guess I shall provide. Anyway, if anything of that piqued your interest, subscribe if you want. Leave me a like, leave me a comment. I'm always happy to answer questions in the comments or take suggestions on video topics or even joke about anything you like. Stay safe, have a lovely rest of the day, and bye-bye.